Hello and welcome back to Calculus 3. We are continuing our exploration of double integrals. This time we're talking about double integrals over general regions, which means that our stencil is no longer a rectangle. So our region now can be anything, like that. So this is now our general region R. Again, domain in x, y. These integrals will still compute the area if we do this, or volume if we do this. So the underlying set is the same. I should have put R as the limits over here, the region. So what's new? Well, what's new now is that these lines that we see over here will create some kind of functions which we are going to integrate in our limits. So I will do a very basic example to illustrate how all of this works. And then we'll write some definitions in red so that you can enjoy memorizing those. So imagine a parabola that goes from 2 down and from -2 up. And the region R is trapped between those two parabolas. Now, clearly, these two parabolas, because they are symmetric, will meet on the x-axis. And those will be some numbers a and b which you can easily compute by either setting these two parabolas equal to each other, or you can solve one of these parabolas equal to 0 and get them because they're at the same time x-intercepts. That doesn't have to happen. I'm using literally the easiest possible case in the galaxy just to explain how the limits work for these new integrals over general regions. So you see that this region is not rectangular, and region is very well defined through these two functions, the upper function and the lower function in the eyes of xy, which is our domain. Please understand that the object is on top, currently pouring from the board or the screen right towards you. So there is some kind of z that is closer to your nose than the surface of the screen or whatever you're looking this, right? Watching this in notes or the screen. So there is some shape above it. So to find the volume of that shape, I am going to use this a and b on the outer integral, and that's my dx integral, because a and b are on x-axis. And then the inner integral will have these two parabola functions as limits, and that's my dy. And then I have f of xy, right, whatever the shape of the function that it's sticking out towards you is. Now, what are these? Where the one on the bottom, right, which is x squared minus 2, and the one on the top, which is negative x squared plus 2. And I will poke like this and like that. So these are our two, from bottom to the top. Is it row dimensional? Sure, you still have dy, you still have dx, and you still have f of xy, so that's f of xy z, so z times x times y, it's a volume, right? So it's definitely a volume integral, but you see that your limits now contains functions. And I will write this immediately, again in blood. Switching order of integration is a living nightmare now. You can't just swap dx, dy and end up with functions of the outer, right? You see that you cannot do that. And for this problem, I don't think that you can actually even do switching unless you're going to write two integrals and have a lot of unnecessary pain. Because your outer limits must be numbers, cannot be functions. That you have to understand that immediately. That when you are setting up these integrals, the outer integral must be numbers. Because the final calculation is the outer integral, and the final calculation has to plug in final numbers in order for you to have a number, which is volume, like 7 or 1/2, right? So I will write here in blood, not easy to switch. Order of dx dy. Sometimes is impossible. So there are cases when you can, and actually switching would be helpful. There are cases where you can, and the switching would not be helpful, would make it worse, like in this case. And there are cases where it's impossible to do it. So that all depends on what kind of functions are already there as a domain. Yeah.
Why did you say the inside integrals have to be functions?
Well, we see that we have functions as limits, right?
Yes.
So what I'm saying is that the outer one must be numbers, which by process of elimination means that the inner one has to be functions, right? The outer one must be numbers because that's your final calculation. And final calculation has to have a number as the answer because that's your volume. Beautiful. So now, how do we deal with this? Well, let's just pick up, well, maybe I should write, let me write the definitions first, and then we are going to deal with examples. So guys, this is generalization of the rectangle. You can, plug your rectangle here, but why? You can do so much better with previous section if it's rectangle. So the double integral over general region R of a function x, y, dA will be computed as a, b, and then integral of g of x to h of x of f of xy, and then this clearly has to be dy dx. Now, I again use the word clearly. I'm not sure. Wait, what just happened?
Didn't save your thing and shut down. You got rejected.
Wait, I'm not sure what just happened.
I think the computer was
They said OneNote stopped responding. Yeah. OneNote.
I actually didn't see it stop responding. But did was there anything in between this, or I?
You were just allowed to write.
You're actually still writing the next part.
Oh, I was just writing the definition, right? So I didn't lose much. I lost the definition, which I can rewrite quickly. Okay. Haha. All right. No, I'm gonna get it off the. Yeah, the OneDrive thing, and I won't have these issues. Anyway, a to b function g of x, h of x, f of xy, and then clearly dy dx. Now, why do I say clearly? I'm going to erase this, so just look at it. The inner integral must be dy because y is g of x, right? And y is age of x. And a and b are numbers that correspond to x value. If you are doing the other one, you will have c and d limits on the outer, and then g of y, age of y, f of xy, dx dy. You see that the inner integral now, if I am to do this on the inner integral, you see how x is g of y. You are not always able to switch from y as g of x to x as g of y. You are not every function has an inverse. And that's why sometimes it's impossible to change order of integration. And sometimes it's a living nightmare, and sometimes it's actually helpful. So, study these concepts. Get familiar with how these things work. You already should know that the inner integral is computed first, and then if this function is in terms of x, then this better be dy, otherwise things don't work out. And make sure that on the outer integral you always have, as you can see, numbers, right? Because you are calculating finite value. So now we're going to use this in an example. And let me pick something from homework. First is just going to be, kind of meaningless calculation, and then we are actually going to do real problems, which you actually do have to set up in engineering. Now, pay attention with this section, as engineering work depends on this. I told you 5,000 times, I really can't care less if you finish the class and you can't integrate, because we have machines to do that. But if you cannot set the integral, if you cannot set up the integral, you are worthless in your field. Sorry to say that, but your job today is not to know that the integral of x squared is x cubed over 3. You have Mathematica for that and computes it in less than a fraction of a second. But if you don't know how to set up the integral looking at the shape, that's the issue. So pay attention on setups. And then, I know you can integrate to most of the extent. Let's say you know how to integrate. So let's take a look first at the basic calculation for whatever problem. 0 to 3. X squared to x plus 6 of x minus 1. And I will say clearly has to be dy dx, because the inner integral has x plus 6, right? So that's y equals x plus 6. So inner integral better be in terms of y. You can also think about, okay, so when I'm done with the first integral, the answer will be in terms of x, and then I integrate that in respect to x to plug in numbers and be done with all of the variables. Right? It's like a game of which way you arrange these things so you end up with a number. And if you mess up in any way, you will end up with variables at the end. So when you solve both integrals, if you still have x's or y's hanging around, it's definitely wrong, right? So you just have to make sure that the ordering of these things are done properly so that you end up with 7 or 1/2 or pi over 6. So now, the inner integral, you copy 0 to 3, which is the outer. The inner integral is clearly x squared, no, I'm integrating in terms of y, so it's xy minus y, computed from x squared to x plus 6, and you still have dx to deal with. Now there's going to be a lot of algebra here, right? Because you are supposed to plug in these functions, and then for each y, and then work out the algebra and simplify. So what do we have? We have x times x plus 6 minus x plus 6, which is first calculation.
X minus 1 times x minus 6.
No, we're plugging in for each y. So it goes here and it goes here, right? So that's the first. And then minus the lower, right? So minus x times x squared minus x squared dx. Let's use the square brackets. So do we see that the upper minus the lower? Everyone? So technically this was your y before, and this was your y, and this was your y, and this was your y, right? This was your y's from integration when you plug in the upper limit and then minus the lower limit. So now you grind through all of this algebra to come up with easiest. So you have x squared plus 6x minus 6 minus x cubed plus x squared dx. Then you simplify that into a single expression. What do I have? I have 1x cubed. X squares, I have plus 2x squared. Then I have plus 5x and minus 6. And then we just integrate that. So negative x over 4 plus 2x cubed over 3 plus 5x squared over 2 minus 6x from 0 to 3. And now we plug in 3. So 3 to the 4th is 81. So negative 81 over 4. Plus one of the 3's will cancel. So we are left with 18. And then 945 over 2. Minus 18. So those die. I have over 4. So negative 81 over 4. Common denominator times 2. That's 90 over 4. Which is 9 quarters. How'd you get 7x? Because this is 6. 6 minus 1 is 5. X minus 6. Awesome. All right. 9 quarters. Bueno.
Are there units associated with the answer, or do the units have to be defined in the question?
The units have to be defined in the question because you will be measuring the object, which is a physical object, in centimeters, millimeters, inches, right? So it depends on the input in terms of units cubed,
Okay.
right? So that will be units cubed in this case. And how I know it's units cubed? Because stuff and then 2 dimensions is 3 dimensions, so it's volume, definitely. So units cubed. Anytime you have stuff on a double integral, it's volume immediately. Great. So the next question is a question 28, and this is the one that you should star and really pay attention to. It says compute the integral over the region for x plus y dA, where the region is in the first quadrant, so Q1, right? It's not QI, it's Q1, Roman numeral. So first quadrant bounded by x equals 0. I usually like to put the region and then arrow. So x equals 0, y equal x squared, and y equal 8 minus x squared. So technically, if you cannot graph, you are doomed. It's very simple. Because you will not be able to visualize if you can't graph it, and without that you don't know what your limits are. We clearly see that we have to integrate x plus y. but you don't have information whether it's dy dx or dx dy, and you also don't know how to set the limits up. So we are going to graph this. Now I'm not worrying about anything else other than the first quadrant, because that's what I said, first quadrant. So we draw xy coordinate system, and I have x squared. Now the other one is more important to graph first, which is 8 minus x squared. So 2, 4, 6, this is 8, right? And 2 root 2 would be the x-intercept. So I don't know, something like this, 2 root 2, right? Because that's the square root of 8. So the upper one looks like this. That's that function. And then we have x squared, right? So at 3, it's going to be 9. So it's going to look like this, right? So this one is 8 minus x squared, and this one is x squared. And I also have x equals 0, which is this. X equals 0 is y-axis. So there's our region.
How does the x plus y work then?
We're integrating that, so that doesn't work in the, that's not the part of the region,
X,
right?
Y, Z is equal
This
to-
is, yes. So this is our region, right? Which is our picture, which is only the input, which is the limits of integration. So that's what we have. So now, I see that there is this intersecting point right here, which is clearly, right, 0 to that x, because that is the most that it's out. So my delta x representative rectangle will go from 0 up to that point, and then it will stop. So I have to figure out what that value is, and I hope it's 2. And I will get that point by going x squared is equal to 8 minus x squared, which is 2x squared is equal to 8, which is, oh yeah, x is plus minus 2, so it's positive 2. Nice. I hope you're ready to witness the miracle, right? We have x goes from 0 to 2, and I immediately put dx on the outside. So guys, look, I'm doing pairs here. 0 to 2 are limits on x-axis, from 0 to 2. That's how much it stretches on x. So when I put 0 to 2 on x, I put dx on the outer immediately, which means dy is on the inner, the bottom function is x squared, the top function is x minus 2, and then we have this x plus y, which is the one we integrate. For those of you who are visual, I'm going to move this. I'm going to draw something else over here in the corner. I hope it will be helpful. I'm going to draw representative rectangle dx, which moves from 0 to 2, and it's stuck between x squared and 8 minus x squared. Please note that this dx representative rectangle is the one that is on the outer, and you see that we know that dx moves left and right, right? So dx starts swiping at 0 to 2, and the top and bottom are always squeezed between same functions. The top is always writing 8 minus x squared. That's your upper limit on dy. And so I hope you guys see that the dx is the swipe left and right, and the dy is actually how this one varies up and down between those two functions, which are squeezing right from y direction. So you have a vertical founding on the rectangle, and then it moves left and right between 0 and 2. Go.
Could you do this the Calculus way if you broke it up as 2?
Yes.
Right?
Yes. So if you are to cut over here, right, y equals to 2 line, and you have this function minus 2. But in next few examples, you will lose that ability. Yes, but we are still kind of setting these things up.
I have a question.
Yes.
I guess it's kind of related to what you said, because the inner integral, is that like finding the area between curves?
Yeah. Yes. Because that's exactly what's area between two curves. And then times another dimension. It's top minus the bottom, except now that functions are numbers. Yes? Sorry? It will be volume because of x plus y, not because of this. As you can see, this dx, dy, they only compute the area between two curves. And I will have to write that. Let's solve this problem, and I will write it on the tablet, but before, I'm just going to put it here on the board, since you already discovered it on your own. The good old integral before, which was a to b for area between two curves. A to b of upper function minus the lower function dx can be written now in Calc 3 as a double integral a to b for dx, and then dy, and your limits of dy are clearly these two puppies. It's the same thing, because remember, this is 1 in order to be area, right? Has to be 1 here. So when you compute 1, you will get y, and then you plug these and you get this formula. See that? So this is just generalizing. This is why I love mathematics. You learn one concept, and then you generalize that in a higher dimension or with a higher concept. So technically, you keep kind of compressing things and expanding in space. So if you learn every step along the way, you don't lose anything. Everything eventually becomes this tightly packaged deal where you know very few things and you can quickly extrapolate to anything else. So
What is extrapolate?
you know what it means.
Yeah, I do.
Good. So now we are going to integrate in respect to y, 0 to 2, xy plus 1/2 y squared from x squared to 8 minus x squared dx. A lot of nasty algebra here, so pay attention. I have... Yeah, I know this is the most annoying part, is actually working out the algebra of these problems, making sure you don't mess up on any minuses and things like that, which is hard to do. So we have 8x minus x cubed plus 1/2, holy nightmare, minus x cubed minus 1/2 of x to the 4th. At least I can do that one immediately. 0 to 2. I will combine what I can, which is 8x squared, or 8x minus 2x cubed minus 1/2 x to the 4th, and then I gotta square this thing. Plus 64/2 is 32. Minus 2 times, that's a 16. Half of that is 8x squared. Minus 1/2 x to the fourth dx. So now combine more like terms. X to the fourth should go first, so minus half, that's just a minus x to the fourth. Cube, there's only minus 2x cubed. How about x squares? Minus 8x squared. How about single x's? I have plus 8x, and then I have plus 32. I hope you're all happy with this.
Nope.
Happy.
You mean like this or like mildly?
You should be happy with this. The alternatives are much grimmer. X to the 4 over 4, so that's going to be minus 1/2 x to the fourth. 3, so 8/3 x cubed plus 4x squared plus 32x from 0 to 2. We don't have to plug in 0 because that it's a polynomial, but be careful. E to the x is, right, when it's 0 it's 1. Cosine of 0 is 1, so you can't ignore 0 every time. Plug in 2 to the fifth is 32. So I have negative 32 over 5. Minus 1 of the 2's will cancel, so that's minus 8. Minus 16/3. And then 4 is a plus 16. And then plus 64. What happened?
Minus 48/3.
Where? Here?
64. No, 48.
It's 8 times 8 is 64/3.
That's what you said, clearly. Look at the board.
Yeah. Exactly. So 64 plus 8 is 72. So we have 72 minus 32 over 5 minus 64 over 3. Right? And that's equal a number. And that's the volume. All right. I mean, you can find the common denominator of 15 and then 72 times 15. What happened? We are in Calc 3, we really don't care. Yeah.
That's the one that gets me in Calc 2 class. They were like, he doesn't even use numbers. He just uses enough to like, so that we're not only using words like cosine, tan, x. Like, there are no numbers.
There are no numbers, exactly.
What's the root of that?
You are past that point. Plus, the number is abstraction, guys. I mean, come on. It doesn't even exist.
The joy on your face when you talk about that, you're like, yes, face number.
What, Calc 2? It's Calc 2, of course. It's like constant burning like hell, except nicer.
Not the lowest level though, that's all.
Okay, what else is there? Oh yes, the definition. So, Mark, you suggested this, right?
So just what?
Yes, yes.
Equals number.
Oh no, Matt. Matt, you said this. No, who suggested this?
Oh,
Alec.
the area between two curves?
Yeah.
That was me.
That was you. Okay. So
Why?
Mark.
That's a bad idea.
I didn't suggest, I just asked.
Mark 1840. How about that?
Is that a Bible verse?
Probably a Bible verse.
Okay, here PM.
Hold on, it's 1855. It's 1855.
You're so weird.
Integral a to b of f of x minus g of x, which is area between two curves. Anyways, it's calculus. We are out to have fun. A to B, and then f of x on top, g of x on the time. Exactly, it's military time. It's actually called normal time. It's only. You know how it goes. U.S. has its own special ways that are, you know. This is European time. Like
That's how John does it, and I always have to do math when I want to, like.
it's
figure
just
out what
minus
time it is.
12.
Minus 12 if it's above 12.
Yeah.
Seriously, is it that hard to subtract?
It's really hard to do that minus 12.
No, it's not. When you're born. When you're born and you just use it all the time, it's not. For me, it's more natural to look at and say 1850 than. But anyway.
The only one that messes me up is 19. It doesn't feel like
19 is 7, yeah.
17 feels like 5. 21 feels like 9.
9.
Which is already
But
thing.
19 is a tough one, right? Okay, fine. Anyway,
I like
cool. Next example.
it's not my. They call me.
That's a great song.
All right, how about you guys enjoy one of these on your own? Let's see.
Oh, thanks.
Ooh,
Faith in us. You think we can do it?
of course you can.
Well, I know I could do it. This is a high number.
Once again.
Look at this.
Confidence.
Look at the limit. 0 to pi over 2. What's about to follow this? Trig, exactly. I know how much you love it. I handpicked this only for you because I love you all.
Negative sign.
Look at those limits.
Can we start with negative?
Now, hold on for the function because that's easy.
You're mean!
You got this. You got this.
Come on.
I feel like this summarizes my day.
Oh, 3 steps. There is something over here for everyone. A little trig, a little these,
There's
right?
no chocolate.
Little bit of pies, that's for me.
I'm gonna go home and have a pop.
Did you say a pot pie? I love pot pie. Do you like shepherd's pie?
Yeah.
Okay.
It's the same thing.
No, they're different. It's a different meat base usually, and they use a different type
It's
of.
different, but that's it.
No, they use a different type.
So it's not
Yeah. Yes. No, but the shepherd's pie will sometimes have like a cross. No, it has like a potato.
Oh.
Like.
Yeah.
Yeah. No, they do, but it's
Alright,
not.
but it's inside.
I love food. What? Trying to eat my feelings. Okay, I'll give you that one.
You still have feelings, you have me.
I am kind of. I'll give you that. And I do.
You got 7? Got 7?
3.14.
Yeah, I was just wondering if you should have this.
He was like six
So I missed 3 launch lessons. It doesn't apply to this. I was
I'm still looking tall.
It has to be, don't even when you learn how to talk about it.
So we're
Is there like a strategy for everyone to get into the library? Not feel it out.
There is a strategy. One, in some cases, you will have to do the XDY. In some, you will have to do the DY dx. In some, one is easier than the other, and in some, like rectangular, it doesn't matter. So So that's, that's going to be literally you doing like 5,000 columns to do that. There's something that I can't really teach. I can show on each problem for each natural, right? But 700 years of experience. So. Oh, I've seen that before. I've seen that.
This was the easiest one.
No, me too.
This was easier than the last one that you did by like a mile. I didn't involve all that
I
crazy.
know, like, you couldn't have given us a whole problem.
Oh, that
Almost.
is almost.
It involved just.
I didn't think of it that way.
Yeah, it's not that hard of a problem.
Oh yeah, that's easy.
Okay, no. Let us have this.
Let me have this.
Nice. So technically, just look at it, right? Yeah, some people literally wrote two things.
That's all you need.
That's all it means. Yeah.
I didn't swap them.
No, you can just write the answer.
Yeah, but there are 3 parts.
The answer is 3 characters.
Yeah. I'm going to say steps. Two steps.
Oh,
It could be done easy. Unless you write everything.
Okay, so integral of cosine e to the sine. That's each side, right?
You should ask Mathematica. Why are you using some random website? I sent you $1,000 gift and you'll use it.
yeah, that's
Right.
not again.
I already downloaded on this too.
Come on.
These computers, all the computers, should have it already.
All the computers on this floor should have it.
Yeah. Of course, this is what
Like they
you
were in a math class?
Yeah.
And you were like,
Why would I use that?
My English teacher doesn't love a good mathematica.
So,
Girl, look at my notes.
coffee.
Coffee.
Wait, you didn't plug in the link. That's why. Erase everything.
Open Mathematica. Are you using all
yeah.
Oh,
Oh my god, I just said that so much.
I was Mathematica for years.
You should see how colorful the books are.
no, the ultimate calculus. No.
You would spell
Try right
Got it?
now.
Yeah,
like the same
somehow I
as
tried a lot. Like, this is
very
that's it. Okay. So, other stupid questions because I've been studying for but
Oh, it is.
which
I
is
know it's that.
I mean, they're probably not extra credit anymore because time has passed.
I
But
have
utility quizzes online.
Quizzes online are all
You need a big chunk of
on the quizzes. We have a pad for homework and a pad for quizzes.
They're all extra credit too.
Yeah.
Oh.
7 quizzes for 7 days. They will be for exam 3 again.
That is before.
Yeah, before. Every day.
No, no, no.
All right, guys, let's do the calculation for this and then do another example. So,
Try both of ours and call it this kind of stuff.
So, are they still active though? Can you
they open
reactivate
and close.
them?
Talk later. Let's do it. So the first thing is I am integrating the inner integral. And as we can see, the entire function is in terms of y, and we integrate in terms of x. So all we're going to get is e to the sine y, because the whole thing is, right? The whole thing is in terms of y. Now, the limits are 0 to cosine y. So now we get cosine y e to the sine y minus 0, so I don't have to write that, dy from 0 to pi over 2, and we see immediately that we have to use u sub, so u equals sine y, du is cosine y dy, so the whole integral turns into simply e to the u du. Now we have to swap the limits as well, so the bottom one stays 0 and the top one becomes number 1 because sine of pi over 2 is 1. So we transformed everything and we get e to the u from 0 to 1, which is e minus 1 as the answer, which is what many of you had. So the answer is e minus 1. That is the volume of the shape. Now you can go Mathematica and you can graph this. Right? You will graph sine e to the sine y on a 3D plot, and you will see how it looks like. Then you can also turn it in space and check out the whole thing. Okay, so let's take a look at one more. This is problem 49. And it says you are to integrate double integral the region 3xy dA, where region is bounded by y equals 2 minus x. Don't forget to graph this, otherwise you're doomed. Y equals 0. And x equals 4 minus y squared. How's the stream doing? Stream is doing well. It's not crashing. I'm happy. 5? Whoa! Hello 5. Why do I have 2 of these open? I'm just gonna close them all and reopen. Okay. So you have the region 3xy dA. You really can't set anything up until you draw the picture and see what is the proper order, dx dy or dy dx. That you can only see from the picture. Yes, the region. Region is the key to everything. Yes. So we are going to take a look at this and see what kind of region we get. So I'll graph the region. You should be able to graph this because it's important. I have 2 minus x, so I go to 2 and then minus x. That means linear line 45 degrees going downward. So that's 2 minus x. Y equals 0 is x-axis. And then x equals 4 minus y squared. 4 minus y squared. So how does that work out? What is that?
Well, when x equals 0, y equals 2. Just like the other equation.
Okay, but someone's saying something on square root. What do you mean square root? Oh, you flip it around, right? So you solve for y, so y is equal to 4 minus x, right? And then there is a square root, and then there is a plus minus. Is that what you want to do? But how do you graph this now? That's it. Graph it sideways. Y equals to 4. And then just make this thing go like that, right? So where is the region where we have all three of these in use?
It's that thing that looks like a whole pizza attacked by only 2 people. What we got left over.
Yes,
What?
exactly. No, he got it.
There's only need like 2 or 3 slices and pork. Please.
Oh,
Yep.
no, I ate the whole pizza.
That's region R. So now that we know where the region R is, which one is the boss, dx or dy? Which is the outer one? Clearly dy. Very good. So we can see that dy is the main order of integration, so that's the one that goes on the outside, and dy has to be on the dx has to be on the inside.
How was this decided again? I don't get this part.
Yes, okay.
Well, here's how it's decided. Observe what's happening as you see. You have to have this, guys. You have to have this ability to move this in your head, and look at this. If I am to draw dx, right? Dx has to go left and right. Do you see how if dx is here, the top still has the same function, but the bottom has a different functions? Where if I have this shape dy, this one always rides on the linear and this one always rides on parabola. You see that? So this is how you know which one is the outer one.
That's
So you don't want it to switch functions on any of the ends. It has to ride the same function throughout to swipe from one end to the other. Sometimes it's dx, sometimes it's dy. So in this case, it's clearly dy. So outer limits are what? 0 to 2. And now we need to work on either. Yes, Sam?
How do you know to take the top and not the bottom? How do you know to exclude bottom?
Well, you see the 1, 2, 3 bounds. So this bound, let me exaggerate. That's that bound, a linear line. That's that bound, which is the x-axis, and that's that one, right? It's the only region that it's stuck between these three. All other regions.
The other little triangle isn't bounded, because it's not bounded by the y-axis. The y-axis isn't one of them. So think of it, that's like not even an enclosed region. That would just be just because the y-axis, like you're gonna erase like the little y-axis.
You're talking about this one over here. Yeah.
Oh, that, oh, the one below. Yeah. It's enclosed by all four. Oh, so then
Wait. Hold on.
area, you just change over 0 boundary, right? You change your limit. Limit to negative 2. No, it's bounded by y. No, it's
Because it's bounded by y equal to 0,
so there's like 2 separate.
You have to specify the quadrant.
it doesn't specify the quadrant. Oh no, it does say in the first quadrant. Oh my god.
Come on.
In Q1. So no, I'm not here. I'm switching to the textbook. I don't want to be stalking the deck. Okay, 49 in the first quadrant, right there. In the first quadrant. Good.
Now we both.
All right. So the only thing that is left now for us to do is to figure out what are the functions that go on limits, right? Now remember, when you have dx, it's going to be top minus bottom for y. When you have dy, it's going to be right minus left for x. So right is our, so the upper limit would be the right one, which is the 4 minus y squared. And left one is the bottom limit, which is 2 minus y.
Now, do you have to write that in terms of, oh wait, oh, you just wrote it in terms of,
Use an independent woman. You write it like you want.
I'm looking at that versus the first one, y equals 2 minus x, so you just rewrote it in terms of
Yes,
x equals.
because this one is x, right? So this has to be x1 equals and x2 equals. And these limits on the outside are y1 and y2. So they have to be in terms of the function y. If you write it in terms of x, the second integral is in terms of y, that x is going to survive. And the answer will not be a number. It will be 3x or something.
Maybe that's the kind of world we need.
No.
Nope.
Oh,
Wait, what
maybe
is
this
x
is gonna
plus?
square, and then you have to square the.
So now the integral is 3/2 x squared y from 2 minus y to 4 minus y squared. Still have dy to worry about. So 0 to 2. We have 3/2. Now we're plugging in 4 minus y squared minus 2 minus y squared. All of that times y, and then we have dy. Then we work out the algebra. We love that. To kick out 3/2, that doesn't have to be an integral. What do I have? I have a 16 minus 8y squared plus y to the 4th minus 4 plus 4y minus y squared, everything times y dy. So that's 3/2 integral 0 to 2. So y to the 4th is the largest times y, so y to the 5. Then I have all these squares, so that's negative 9y cubed. Then I have 12 plus 12y, because I had to multiply by this y on the outside. That's why these exponents are off by 1. And I have dy. So now we will integrate 3/2. Square is cube now. Because you have a square, and square that makes a negative 9 times y is negative 9 cubed.
What about that 4y? Is that canceling or something? That's to the minus y.
Oh, there is a 4y there. No, I just skipped over that one. So plus 4y squared. Oh, come on.
What is this? Minus 9y cubed plus, now you're back to where you
Plus 4y squared
plus 12y.
plus 12y dy. Okay, so mark plus 5 on the next test, and Joe and other gone minus 5 on the next test. 1 over 6 y to the 6 minus 9/4 y to the 4 plus 4/3 y cubed plus 6y squared from 0 to 2. So 64/2 is 32 over 3. Minus 2 will cancel of this, it's 36. plus, that's 832 over 3, plus 424. Zeros will just die. Now I put the front to kill all of the fractions, becomes 16. And then half of 36, 18 times 3, 54. Plus 3 dies 16. Plus 12 times 36. So 16 and 16 is 32, 68 minus 54, clearly 14. As I said.
Wait again. So you have to subtract off that little piece, or is that already calculated?
It's not calculated in there because your limit started at 0. Otherwise, your limit on y, which was the outer integral, would start at, I don't know, let's say this is -1. Then this limit over here, let me actually put it in color so you can see it easier. This limit over here would be -1 if this is -1 elevation. So that's why I had to go back into the problem and make sure that that thing quadrant 1 is there. Because if that word in quadrant 1 was not there, we would have to compute this point and use it here. And then this would be allowed to swipe from here all the way up to there. Still stuck between same two functions, right?
Also, why would they say y is 0? Why would they put up the problem?
Well, that's the only reason why I immediately boxed off and stopped reading, because if you don't want to make a stop there, right, anything else is not bounded, right? Nothing else would be bounded other than that. Cool. All right, let's see something else that you might hate. What happened? One more problem, which is going to really make you want this break. The statement for this problem, maybe I should do it red. It's going to be too intimidating. How about purple? So this one says change the order of integration, which means switch from dx dy into dy dx or whatever other way. And pretty much any of these problems are equally bad. Ooh, we have a 66. Let's do that. It's just because, yeah. 0 to 4. I'm still doing purple. I don't know why.
I like it. Don't pick all the things I said that.
We have 0 to 4, square root of x to 2, x over y to the 5 plus 1 dy dx. So, as you're looking at this integral, you immediately realize that you can't integrate at all. Because you have to integrate in terms of y, and look at the function. It has y to the 5 in the denominator, right? Plus 1. There's nothing you can do. Well, you can try, but other than that, there's nothing else you can do. There's no integrating this. So, if this integral is not possible to change order of integration and then integrate that way, you would actually have to do some of those numerical integrations in this, which means writing the code, right? So, change the order of integration. Now, does anyone have any idea how would we go about changing order of integration? I already told you you can't just swap them.
Guess
The
and
y
guess.
is in terms of x let's see, if y equals 2 and y equals square root of x, or solving for x. Not on track at all.
That's a start, but something crucial that you actually have to do.
Partial derivatives. Partial integration.
What? Partial
That doesn't even
integration?
exist.
Yet.
I was gonna say.
So what do we do? What do we do?
Yeah, outer,
We're gonna have to graph
the
it.
numbers, right?
We ask our Lord next for help.
We have to look at the two integrals with the limits, and we have to graph this function looking at those limits. Okay, so you have to come up with a graph looking at. So the way to do this is to graph the region looking at this. That's all of the information that you need and that you have. Well, this is a little bit helping, but this thing has nothing to do with anything in terms of region, and even when you swap stuff, that stays as is. So you will never be changed, well, not never. In the next section you will be. But right now, when you change order of integration, this will remain, right, the integrand will stay the same. Your job now is to try and break your heads a little bit to figure out the graph out of that mess on integrals. So those four values, 0, 4, 2, and root x.
So by doing that.
So figure it out. Try to make a graph with it, right? Try to make a graph, and then I'll give you 5 minutes, and then after that, I'm going to think out loud and make that graph. And that would be the end of this section. It's okay to talk to people next to you and share ideas and so on. Your job is to,
So then,
everyone except Emily.
I don't want to ask Alex
and it's from 0 to,
because he smells bad.
so, it would be this.
And as you explain how you pick a side building for, the functions are the same for like the opposite sides, no matter which angle you look at it. So you can choose which one you want to do.
Nope.
Why did your wife?
There's a-
Why
You can, because that's okay. Neither. This is always the same function, and this is always the same function. This is always the same function.
I know.
And this is always the same function. I think I'm saying.
I just want to express my upset that like
What am I
the
saying?
top thing on my
You're
Amazon
extremely
Prime
close.
suggested
Extremely
for
close.
you is, like, big glove.
Well, I'm
Everyone,
gonna sit here then watch everyone
I'm
else
not
do
trying
that.
to, yeah, you can leave it there. That's pretty good.
But they really are painting.
I need to talk to you. I don't know like that.
No.
Okay.
Like, you know, my place is a Christian, like,
That's a trigger.
well, that
Wish it was.
that place.
All right, let's see. Okay, so here is what I read from this graph. I first look at the outer integral, and I'm going to write x equals 0, x equals 4. Now on the graph, those are vertical lines. X equals 0 is the y-axis. 1, 2, 3, x equals 4. So 0 and 4 on x-axis. Then I read the inner ones, and I have y equals to 2 and y equals to square root of x. Y equals to 2, and those are the light green. So y equals to 2 is going to be horizontal line through 2. And the square root of x, which is square root of x function, does this, goes through 1 and then hits this one. So it looks like this. All right, now I have clearly two regions to pick from, this one or that one. It's one or the other, and it's clear which one it is. So it's not a chance. I have to find a region that it's bounded by these values. So now, which region is bounded by these values? I have to go from 0 to 4 on x. Now both regions start at 0 and end at 4, right? This upper region ends at 4 in a point. The bottom region ends in this interval of 2. So these both regions fit here. Now look at this region here. It says that the upper is 2 and the bottom is root x. So it's this one right there. So I'm going to write this now. This region here is 2 on top, root x on the bottom, and this region here is root x on the top and 0 on the bottom. Do we all see that? If I'm to draw delta dx rectangle, the upper region will have that dx stuck between 2 on top and root x on the bottom. And if I'm to draw that delta x on the lower region, it's going to be 0 to root x. So that's the reason why it's clear that it's the upper region that we're talking about. So now that I have the region, I'm going to erase these purple things because we don't need them. So it's clear that it's upper region. So now I have to write completely new integral, which will still have this x over y to the 5 plus 1, but now it has to be dx dy. So dy is in charge, which is delta y, right, sideways. So I'm going to draw delta y here and ask myself where that delta y lives, right? Well, delta y lives from 0 to 2 on the outer integral, right? Because the lowest it can go is elevation y equals 0, and the most it can go up is elevation y equals to 2. So those are my new limits on the outer integral. Now the inner integral is the right one minus the left one, but they have to be x equals both. Now clearly the one on the left is 0, right? Because the bottom of the dy, the left side that it's touching, is x equals 0. And you see that it's riding on the function which we had before, y equals, so maybe I should again, let's invoke purple. So this function here is x equals 0, which is our left limit. And we know that this function here is y equals root x, but we have to write it as x equals stuff, which transforms into x equals y squared, which is your upper limit, y squared.
We have to write it in terms of y.
Because it is a dy rectangle, and these limits have to be, because you're integrating in respect to x, it has to be x equals a function and x equals a function. So when you solve this piece for x equals, it's going to be x equals y squared, so that goes up there. Now, we solved this. Now you can integrate. I hope you see that you can integrate now, because now you're integrating in terms of x, so this y to the 5th plus 1 that was issued before is just a constant now. You copy it, right? I know, lots of joy, right? So I have x squared divided by 2 times y to the 5 plus 1 from 0 to y squared dy. And look, how beautiful is this? Y to the 4th over y to the 5 plus 1 dy, and you hit it with u sub, and it's done. This is how wonderful this stuff is. So what I get is, no, 0. Plug in 0, it becomes 1. Plug in 2, becomes 33. and we have 1/5 du over u, which is 1/5 integral u to the -1 du, which is ln. Well, I just write ln. So ln absolute u from 1 to 33, which is 1/5 ln 33. You don't have to calculate, write 1, ln of 1 is 0, so that dies. Why, I dropped a half? Oh, good. 1/2, so that's 1 over 10. 1 over 10. As you can see, easy to make a mistake, right? 1 over 10. So that's that part. The problem is done. The lecture is done. Very important part, and you've seen it in this problem at the end. You cannot simply change the order of integration. You have to use limits to come up with a graph. Then you have to use that graph to come up with a new integral, because everything changes. The values, the functions, everything changes as you switch the order of integration. And I had that written earlier in red, that you cannot just switch stuff. That was all the way at the beginning, right here. Not easy to switch order of integration, and sometimes it's impossible. When is it impossible? It's impossible when you cannot switch the function around. So this little witchcraft we did here earlier, did it here, right? And in the last problem, we did this, right, when we switched the function there. Those are, when you can't switch those, then you can't switch order of integration. So we're going to end this lecture here, and for the remaining of the time, which is another whatever minutes we have, we are going to review polar coordinates, parametric equations, and all that kind of stuff, because that's what we need for next lectures. Bye, stream.